Here we go. We're going to go and now solve both of these quadratic equations that have a missing linear term. All right, and I'm going to show you a cool way of doing this besides factoring. I'm going to show you both ways here, and you can kind of have more tools for you to use. So notice that it's missing the bx term. So I have my ax squared plus bx plus c, and notice both of these problems are missing this term, the bx. So there is no bx, and that's why it says in the title right here, we're missing a linear term. And the reason why that I know that this is a linear term is because my degree of this monomial is 1, of a degree of 1. And so that's what makes it linear. If it said missing a quadratic term, then that means you'd be missing the ax squared, because 2 means quadratic. All right, so let's solve this by using factoring, because that's, again, what this chapter is all about. But I'm going to show you another way as well. So if I'm going to solve this by factoring, I notice that both sides, or both of my terms, have a 5 in common. So if I factor out a 5, I get this. And now we can go ahead and factor this guy by doing difference of squares, meaning I have a minus sign in the middle, and I think I can write both of these as squares. So like what squared minus what squared? Well, that can be simply put in as x and 4, right? X squared is x squared, and 4 squared is 16. So to factor this, it's just simply x plus 4, x minus 4. So x plus 4, and then x minus 4, and then still equals 0. But don't forget about the 5 over here. Okay, so what do we do with this now? Well, just like we've done in the past 2 examples, you set each factor equal to 0. Okay. Now what about the 5? So check this out. Say if I'm like, you know what, this 5 actually really doesn't mean anything, because technically, if I wanted to, if I divide both sides by 5, I now have x plus 4 times x minus 4 equals 0. And see, so whether you put the 5 here or not, that doesn't matter. So generally, and this is true for every time, if you have a constant factor, okay, just some kind of constant factor like 3, 5, 7, not one with a variable, but just a constant number, then you can actually just ignore it. We're not even going to use it because it doesn't affect the answers right here. All right, so now you set x plus 4 equal to 0, x minus 4 equals 0, and we get our answers as negative 4 and x equals 4. And so there's that guy. Now, but you know what, there's another approach, and I just think that it's a little more effective in a way, but you can kind of make that judgment yourself. But if I took the same problem, 5x squared minus 80 equals 0, okay, so notice that we only have one single variable, right? We don't have an x squared and the x term where you can do what I'm about to do right now. And so basically, I'm just going to use what we learned in just, chapter 1 basically in algebra, which is to solve for x. So no factoring special things. So let's just go ahead and move the 80 over. So I'm going to add 80 to both sides, and I get 5x squared equals 80. Okay, now I want to get rid of the 5 because I'm trying to get x by itself. So I'm going to divide both sides by 5, and I get x squared equals 16. And one last step, I want to get rid of my square. So the opposite of squaring a number is square root. So I'm going to take the square root of both sides. And notice that the square and the square root are opposite, so they cancel each other out. Okay, and the square root of 16, this is the only little trick here. It's not really a trick, this is just basically a truth of mathematics, which is in an equation, if we introduce the radical, so we're the one who wrote the radical in, we need to put plus or minus 4. Basically, like, you need to add in that plus or minus. And that should make sense here, because we look at the answers that we got over here, we have a plus 4 and then we have a minus 4. So notice that we got the same answer, and this approach was just basically solving for x, and the first approach was more using our solving techniques. Okay, so if you want to do that for this guy, which I'm going to do, or you can still do a factoring. So I'm going to go ahead and do it by my second method here. I'm going to go ahead and add 100 to both sides. Get 4x squared equals 100. I'm going to divide by 4 on both sides. and get x squared equals 25. And then I'm going to take the square root of both sides, and I get x equals, don't forget, plus or minus 5. And there we go.